we're tackling eliminate maximum number of monsters, which we're going to try and solve with minimum complexities of O(n log n) time and O(n) space. So in this problem, and rather disappointingly, we're playing a video game where you have to defend your city from a group of monsters. Each of these starts at a certain distance from the city, walking towards it at a constant speed. You have a weapon that can eliminate one monster when fully charged, but it takes 1 minute to charge. If a monster reaches the city, at the exact moment the weapon is fully charged, it's going to count as a loss. Indeed, if a monster reaches the city at any point, it's a loss. The task is to determine the maximum number of monsters you can eliminate before losing the game. We have 4 potential methods to choose from. They are A, binary search, B, brute force, C, count sort, or D, greedy plus sorting. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who are able to get it, congratulations. And for those of you who just want to see some code, the answer here is D, greedy plus sorting. I won't dwell on the brute force approach at all. Needless to say, it uses nested loops, and we can keep track of the remaining monsters' positions and arrival times, eliminating them one by one. The use of nested loops causes an O(n) squared time complexity, which we can improve on. So in our optimized solution, we use a greedy approach, which is combined with sorting. We calculate the arrival times of each monster and then sort them in ascending order. By doing this, we can identify the first monster that will reach the city at the same time or later than the weapon charges. And then we can calculate how many monsters we can eliminate before we run out of time. Now, let's go through the line by line to make sure there's some understanding here. So first of all, our function is taking 2 arrays as input. Dist represents the distances of the monsters from the city, and speed represents the speed of the monsters. The variable SZ is just the size of the distance vector, and then we create a new variable called arrival time, and this vector stores the arrival times of each monster at the city. In the next loop, we iterate over each monster, calculating its arrival time by dividing the distance by the speed. As you can see, if there's a remainder, we're going to add 1 to the arrival time to account for the time needed to fully charge a weapon. After we've calculated our arrival times, we sort the arrival time vector in ascending order using, in this case, sort from our algorithm library in C++. After that, the variable monster is initialized to 0. And eventually monster will represent the maximum number of monsters we can eliminate. After that, we iterate over the arrival time vector and check if the current monster's arrival time is less than the current maximum arrival time, which is given by arrival time monster here. If it is, we increment our monster variable because it means we've shot one of the monsters before it's reached the city. And that's it. After we've gone through this loop, we'll be returning the value of monster, which will represent the maximum number of monsters that can be eliminated before losing the game. Essentially, if this arrival time monster variable is greater than or equal to the index I, then, that represents, by the way, minutes, then it's game over. Although I hope by learning this, it's game on in your interview. So, If you need extra help with studying these kind of sorting problems, check it out in the first part of this Algorithms 1 course, which is available on Udemy and is included in the description to this video. Dr. Ibrahim does a much better job of teaching the concepts and underlying methodologies than I do. Finally, we're going to round off this video with one more check of the best method for solving this eliminate maximum number of monsters problem. And you should have worked out, it's the greedy plus sorting that we're looking for. There's an explanation as to what's going on when we choose it, as well as some example solution code, which has been tested on LeetCode. We have it in C++, Python, and Java too, and all of them correspond with the method on the right. So that's it. Thank you very much for watching, and if you're following the algorithms pack in the learning mode of our application, the next problem is maximize sum of array after k negations.